Okay, I made a quick video just to go over some points with the first multiple choice packet 1973. First one, derivative of e to the 1 over x. The derivative of e to anything is e to that, but then you've got to apply the chain rule, negative 1 over x squared. Second one was this pretty simple integral because it would end up to be x plus 1 to the 3 halves over 3 halves or 2/3. Remember, we can do that where the derivative of this is 1. Can't do that with things like cosine x plus 1 to the 1 half. So a little trick here, you end up with 2/3 times 4 to the 3 halves minus 1 to the 3 halves. 1 to the 3 halves is 1. You've got to know that. 4 to the 3 halves, two different ways. You could say it's 4 to the 1 times 4 to the 1 half, which is 4 times 2. You could also do the square root of 4 cubed, which is 8. So you get 4/3. Third one, where is this increasing? Well, it's increasing when the derivative, which is 1 minus 1 over x squared, is greater than 0. And again, this is going to be algebra. You guys got to practice this. So this, it happens when 1 over x squared is less than 1, which if you look at the answers, you should be able to deduce it's A. Because this is only going to happen when x squared is greater than 1, which means, well, anyway, that's how you solve that. What non-negative value of b is given in number 4? Now that you need to, if the normal has slope of negative 1/3, then the tangent slope is 3. So you can say, okay, dy dx, 3x squared has to be 3. That's at 1 or negative 1, but they're saying what non-negative value of b? So you're going to be forced to the point 1, 1, and you can solve for b. Number 5. Oops. Is absolute value of x over x. And that, there's no way to be doing that analytically. You got to look at that and say, oh, that's going to be a graph where for greater than 0, it's just equal to 1. For less than 0, it's equal to negative 1. So the area from negative 1 to 2 is this positive area, which this rectangle is 2. This area is below the x-axis, so 2 minus 1 equals 1. Number 6, straightforward derivative using a quotient rule. X plus 1, low d high, times 1 minus x minus 1 over 1 over x plus 1 squared. And then you've got to plug in 1 carefully, and you'll get the answer. All right. Wait a minute. There should be some music here. Number 7, you have the derivative of ln of x squared plus y squared. Again, classic chain rule. 1 over x squared plus y squared times 2x plus 2y times y prime equals y prime. That's implicit differentiation. Now look, you could do a lot of algebra separating out and getting y prime by itself, but we've got the point, they're saying 1, 0. Notice y is 0. So this is just going to go away. So you'd save a lot of time by just saying, oh, 1 over 1 plus 0 times 2 plus 0 equals y prime, and you'd get it. You'd get it if you'd solve for y prime up here, but lots of work. This is what we call getting very good at multiple choice. Number 8, sine x. Cosine x, negative sine x, negative cosine x, sine x. So at the fourth one, if you had cosine x, you'd have negative sine, negative cosine, sine, cosine. Number 9, cosine of 3x squared. Now today, Dennis, I know you brought that up, but doing derivatives, don't use any identities. The derivative of this, we rewrite it like this, is 2 times cosine 3x to the 1, underline this, times the inside function's derivative, which is negative sine 3x, but I still have to take the derivative of that as 3, and the answer falls out. This was a tricky question for good reason. dy dx, 1 over secant x times secant x tan x, those need to be in the back pocket, equals tangent x. So for the arc length, it's 1 square root of 1 plus dy dx squared, which is 1 plus tangent squared, which is one of those things you got to remember. From cosine squared plus sine squared equals 1, divide through by cosine squared, you get 1 plus tangent squared equals secant squared. So that little baby turns into secant squared, and the square root of that is secant x. You need to know those identities. Last one, a product rule, x times 1/2, 1 plus x squared to the negative 1/2 times 2x plus root 1 plus x squared times 1. Now again, you could do a lot of work on this, but they're saying what's dy when dx is 2 and what's it, x equals 0. So do you see this whole mess here with x equal to 0 is going to 0. So I can say dy equals 0 plus root 1 times dx, and I'm done. All right, 6 minutes and 14 seconds. Explaining them all. You guys had 25 minutes for it. Bye.